is Unit 3, Matter. Lesson 2, Separating a Mixture. Practice your skills. Do now. 1. Which substance cannot be decomposed by a chemical change? This is the definition for an element, so we're looking for an element. Of these 4 choices, only 4 has only one capital letter in our formula, therefore this is the only element. The rest of these are all compounds. 2. How many atoms of oxygen are in the following formulas? So here I have an oxygen with a 4 subscript after it. So 4 is my subscript, which says I have 4 oxygens. My 4 in the front is my coefficient, which says I have 4 of everything after it. So if I have 4 copper sulfates and 4 oxygens in each copper sulfate, that's 4 times 4, which is 16. For a very similar process here, my parentheses tell me that I have 2 of my NO3s. So that means I have 6 total oxygens here because I have 3 after that one. So 3 times 2 is 6. But this 2 tells me I have 2 total. So if I have 6 of these total, 2 times 6 is 12. So 2 times 6 is 12. Okay, then we talked about the notes in class in detail. So practice your skills. A mixture of sand and table salt can be separated by filtration because the substances in the mixture differ in their solubility in water. The sand does not dissolve in the water, therefore I can collect it in my filter paper. The boiling point has nothing to do with this because I'm not heating it up. The density has nothing to do with this because I have the filter paper. The freezing point has nothing to do with this because I'm not changing the temperature. So these 2 I can eliminate because there's nothing about temperature here. Heating or cooling or anything like that. Density might be a little bit tricky because you might think that that's true, but because the sand does not dissolve in the water, that's the property I'm utilizing to separate it from the table salt. 2. When a mixture of water, sand, and salt is filtered, what passes through the filter paper? So this one might be a little bit tricky because you might forget about the salt. But if I have water and salt together, we know that they dissolve. So my water and my salt form a solution. The sand does not dissolve, therefore it will be trapped on the filter paper. So the water and salt only will go through. 3. Which mixture can be separated by using the equipment shown below? So this is a filtration setup, which you've seen in class and you've worked with. The filtration separates solids from liquids, not aqueous solutions. So even though there's all these symbols and stuff, the only thing we care about are these. So because both of these have aqueous solutions, I can't use filtration. I can't use filtration to separate them. This one has a solid, therefore this will separate. And in fact, this is sand. And NaCl, aqueous, is our salt water. So this is essentially an aqueous solution of salt water mixed with sand. So this is what we use primarily as our example for filtration. A dry mixture of KNO3 and sand could be separated by adding water to the mixture and filtering. So this one might be a little bit tricky just because you might not know that KNO3 dissolves in water, but you could probably figure it out because we're not cooling anything and we're not heating anything when we filter it. With the sand, we're not heating and cooling. So that would have been our indication here because nothing we've done with sand indicates heating and cooling. And if I add water to the mixture and evaporate immediately, that doesn't do anything except bring my salt back to it. So this one's a little silly. So this one, you could probably kind of use your common sense, but the real knowledge to help you is that KNO3 dissolves in water, and then I can just filter out that sand. 5. By which process is a precipitate most easily separated from the liquid in which it is suspended? So precipitate is a word that we're going to talk a lot more about, but that means a solid. So if you didn't know that, that might have been why this one was tricky. But we know that filtration separates solids from liquids. So we don't know neutralization. We know distillation, but that's not this description. And condensation is something totally different, which you should recognize as not being this. 6. Equal amounts of ethanol and water are mixed at room temperature and at 101.3 kilopascals. Which process is used to separate ethanol from the mixture? So this, I told you in our notes, ethanol and water is an example of a mixture that we would use distillation for. Filtration is for solids and liquids, so that's not what this is. Solid and liquid. And then these other two you probably don't recognize, so you can immediately just get rid of those now. Those are not examples of separation techniques. Petroleum can be separated by distillation because the hydrocarbons in petroleum are. So, in order to separate mixtures, we need something that's different. We know that they're not elements because petroleum is not an element. We know it's a compound because we know petroleum is not an element. But if they had identical boiling points, I would have no way to separate them. So the only way I can separate them is because they have different boiling points, the hydrocarbons. And you don't need to know any of these other words to answer these questions. So the tricks here is to look at what we know and pull out our knowledge from that. 8. Recovering the salt from a mixture of salt and water could best be accomplished by. So, this, if I have my salt and water mixed, we talked about, evaporation would be the best way because I can get rid of that water and leave my salt behind. Paper chromatography is for homogeneous, filtrations is for heterogeneous, and density determination has nothing to do with salt water. Or it's not a separation technique. 9. The laboratory process of distillation does not involve changing a liquid to a vapor. That's not true. It does involve that. Changing a vapor to a liquid. That's not true. It does involve that. Liquids with different boiling points. That's not true. That's the key characteristic that helps us separate it. And so if I have liquids with the same boiling point, distillation would not work. Therefore, that is what it does not involve. 10. When sample X is passed through a filter paper, a white residue remains on the paper. Therefore, that's a solid, and a clear liquid passes through. So there we know we have a heterogeneous mixture just from that description right there, because filtration works with heterogeneous mixtures. So when liquid Z is then vaporized, another white residue remains. And so this tells us that my liquid was a solution. Sample X, though, what we're talking about, is best classified. It's not an element because we clearly mix stuff. It's not a compound because it's a mixture. It has different things. So those two we can eliminate. So now, is it homogeneous or heterogeneous? Well, we know it's heterogeneous because I first filtered it.